This is an IR sensor. They are what detect when people go in and out of a room, usually installed in bathrooms. However, these sensors have some accuracy issues, mainly being that when two people go in side by side, they think it's just a single person, which really messes up with it keeping track of how many people are inside. So, what we decided to do was install a camera on top of the door frame and use the video in real time to track the people and determine if they entered or exited the room. Here's a demo of how that went. So how do we do it? Well, first of all, we use several pieces of hardware for this project. A Raspberry Pi with a 64-bit OS, a Pi cam, a USB accelerator, a breadboard, an LED, and a resistor. For the software, on the other hand, we used only one pre-made algorithm, which is Yolov5, which is a deep learning-based model that detects objects in an image and draws a box around them. The camera would take video footage and send it to the Raspberry Pi, which used Yolov5 to detect the objects. On top of that, we wrote an algorithm to use that detection information to actually track the people and record whether they went in or out of the room. But you might be wondering, what's the difference between detection and tracking? Well, detection, as we mentioned before, is done by Yolov5, and it basically is where you find a person in an image and draw a box around them. However, this is done separately for each image, meaning that if you move on to the next frame in the video, all of the data is deleted and it draws new boxes on each person. Tracking is where we use the detection information and connect them, saying that this person is the same as this person. This is important because from the computer's perspective, it only sees the boxes in the image, so it doesn't know which box is leaving or which box is entering the room. Object tracking would tell you which direction the box came from, which you could use to determine if it's entering or exiting the room. The way we track the objects is by saving the previous image, then comparing it with the current image. If a box from the current frame overlaps with a box from the previous frame, we decide that they're the same object and match them together. However, if two boxes overlap each other in the same frame, there is a problem because the computer wouldn't know which overlapping box to match with which. In this case, we took the overlapping area of the boxes and matched them with the ones with the highest overlapping area. Object tracking done. However, this is only the first part done, and we still had to use this data to figure out if a person is entering or exiting the room. We did this by taking the tracking data and seeing if a person's box disappeared at the bottom of the frame. If so, it would mean that the person entered the room. On the other hand, if a box appears at the bottom of the frame, then it would mean they left the room. This information was used to determine how many people were in the room at a given time and displayed on the screen. For those of you wondering, this is a flowchart of the algorithm. Now to actually put the algorithm to the test, we first use a remote control software called TightVNC to access the Raspberry Pi remotely. That way, we could make the whole system an independent unit and monitor it without constantly having to connect it to a computer with a bulky cable. The way we got the software into the Raspberry Pi was by cloning the GitHub folder of both Yolov5 and our people tracking algorithm in the Raspberry Pi, then directly running it. Last but not least, we outputted a signal via GPIO pin in the Raspberry Pi so that the LED would turn on when there were one or more people in the room and off if there were none. So in conclusion, our system was able to properly detect and track people from video footage, determine if they are exiting or entering the room, and record all the information, all within a Raspberry Pi module. Some issues we had was that since we ran this on an embedded system, it wasn't the fastest and the frame rate dropped to around 2.4, which is pretty choppy footage. At the same time, the accuracy wasn't perfect, as it would sometimes detect two people as one person when they were moving one in front of the other. The dilemma here was if we wanted to get a faster frame rate, we would have to use a lighter model, but that would lower the accuracy, which already wasn't all that great. Something we could have done to make it faster without sacrificing accuracy was to use a tensor model. This is because we use the TPU for the USB accelerator, which is optimized to make tensor-based models faster. Nevertheless, we are able to make a completely independent system able to detect and track people going in and out of a room, and frankly, I would call that a success.